learned yesterday. So always yesterday we have started discussing about the concept. Okay. So ultimately our main intention behind the multiple access protocol is so here. Okay. So dear friends, now here if you are going to look at that, ultimately our main intention is whenever if suppose whenever a medium is there, how it can be allocated randomly to the users who wants to use that particular medium. But when we are allocating it, we should see that we should not get any collisions. Okay. So because whenever if the two users wants to use the medium at the same time, okay, then definitely so there may be a chance of collision. So for that particular purpose, majorly while we are going to access to this particular channel, now these are the questions are supposed to be keep in our mind. What is the first one? When can the station access the medium? Okay. Now, if a medium is there, if I am a station, when can I access? The question. What can the station do if the medium is busy? Okay. So, how can the station determine the success or failure of the transmission? Okay. And what can the station do if there is an access conflict? Okay. Now, these are the various questions which you need to keep it in your mind. Okay. So, now based on these particular questions, now how to solve this? To solve these particular questions, we are going to use multiple access protocols. We are going to use multi-access protocols. Okay. So that multiple access protocols, when we are going to talk about, okay. So yesterday I have shown that, see, the multiple access protocols, when we are going to talk about the multiple access protocols, these protocols are divided into random access protocols, controlled access protocols, and channelization protocols. Under the randomization protocols, we have started discuss that random access protocols we started discussing, and we have discussed about Aloha. When we are going to talk about a Aloha, what we have decided, Aloha is going to use, the basic idea is it is going to use ground-based radio broadcasting. Okay. And in the Aloha, we are going to have two types. One is the Abraham's suggested method, and another one is the Robert suggested method. Okay, so one is the pure Aloha and another one is the slatted Aloha. When we are going to talk about this pure Aloha, in the pure Aloha, what we are going to talk about? Simple. No station is going to wait for anybody, and it is not going to check for whether I am able to access the medium or not. What it is going to do, whenever it is having a data to send, immediately, whatever the time it is going to send it. It is going to send it. So that yesterday we have seen a image. Yesterday we have seen this particular image. Now here you can look at pure Aloha. What is happening? Station 1 is having a frame over here. It is sending frame 1.2. It is sending over here. See, and station 2 is having the first frame over here. Second frame over here. Station 3, first frame is over here. After some gap, then it is having the second frame. So now the point is irrespective, no station is going to wait for anybody and it is going to send it. And during that particular period, if suppose if you are going to look at here, if no one is going to send in that particular period, okay, so this frame is going to reach the destination correctly. So in that particular aspect, yesterday when we are going to look at that, so there is a possibility that very minimal number of frames are going to reach to the destination successfully. That is the reason in the pure Aloha, what we discussed, once again, just have a look at. Now here, just now I have said some points. Okay. So now here, when can, okay, 1 minute. Now here, if you are going to look at that, how can a station determine the success or failure of the transmission? See, yesterday I have told that every station can identify whether the frame has been reached correctly or not based upon the acknowledgement, okay, or based upon the sensing, okay. So now, however, now here what we are going to do in the sense, there will be collisions, of course, and the collide frames will be damaged. and these damaged frames should be resent. How it should be retransmitted? So now here you are going to come to know that due to the feedback property of broadcasting, a sender can always find out whether its frame was destroyed by listening to the channel. Now this is a very important one. You need to understand how you are going to come to that. You have to listen to the channel. That is going to be either you can sense it or either you can get the acknowledgement. Okay, so the same way users can do that. Now with a LAN, the feedback is immediate, but with a satellite there is a delay of 270 milliseconds before the sender knows if the transmission was successful or not. Now, why I am talking about this particular thing, in the sense you need to calculate based upon this particular delay and everything. Next time when you are going to retransmit, you need to wait for that time. Okay. So anyhow, we will come back to that. See, if listening while transmitting is not possible for some reason, acknowledgements are needed. See, you must be available and listen to that. If you are not able to listen, what you can do? You can implement a acknowledgement policy, as which we have seen in the stop and wait ARQ and all. Okay. So in the stop and wait ARQ, or what we are going to do, we are going to wait for the acknowledgement, and the moment if we are going to get acknowledgement, okay, that is nothing but successfully it is reached. Okay. So if the frame was destroyed, the sender just waits a random amount of time and sends it again. Now this random amount of time, always please try to remember, this random amount of time is always the binary exponential. Binary exponential back off, we will call it as. So what is a binary exponential back off? In the sense, if suppose you have waited, once if it is destroyed and you have waited for 2 minutes, now again you have sent it, again if you are going to get, next time you have to double it. For 4 minutes you need to wait. Still if you are going to get 8 minutes you need to wait. That is what exactly the binary exponential back off algorithm we are going to talk about. Okay. So the binary exponential back off is nothing but always it is going to double it. It is going to exponential, isn't it? So now that based upon this, you are going to calculate your random amount of time. Okay. Now, so the waiting time must be random, or otherwise what is going to be happen? The same frames will collide over and over. Now that is a very important aspect. Now, dear friends, now here if you are going to look at yesterday, now how you are going to calculate this random time? Now here if you are going to look at that, we have taken TP and TFR, which is the average frame transmission time, and then you are going to use a back off time. You see, as I told that just now, back off, binary exponential back off, TB. Now you are going to calculate the TB over here, and that much time you are going to wait TB time, and then you will come and you will retransmit it. Okay. So now if you are going to look at your Forojan, if you are going to look at Forojan, okay, anyhow, I will come back. Okay. Now, when it will comes to that, the success ratio, vulnerable time, how you are going to find the vulnerable time for a pure Aloha? Now here, if you are going to look at that, it is going to start with a T minus TFR, and this is a T plus TFR. Now here, the frame is beginning over here and it is ending. This particular frame A is colliding with the end of the frame of B. You see here, B's end collides with A's beginning, and A's end collides with B's beginning. Okay. So now here, what we are going to do, in a sense, you will find based upon that, this is a time T where it is going to collide. This is a time T where it is going to collide, and this is a time minus TFR, that is where it is going to be starting. Okay, that, and this is a FR where it is going to end. Now based on that, you are going to calculate the vulnerable time, and based upon this vulnerable time, you need to calculate it. So then what we are going to talk about, so that when we are doing that, the throughput of a pure Aloha is S is equal to G into E to the power of minus 2G. Now that is yielding as 0.8184. Now if you are going to look at that, sir, how it is going to come and where the explanation and everything. Okay, now here, dear friends, if you are going to come to this particular thing, Aloha, now you can come over here, Aloha, pure Aloha. Now here, when you are going to look at the pure Aloha, now here the explanation in the Tenenbaum book. Okay, this is a Tenenbaum textbook. Okay, In the Tenenbaum textbook, now here if you are going to look at that, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 10, 4 frames are reaching perfectly. 4 frames are reaching perfectly. Now here if you are going to look at that, A's end is collide with B's beginning, B's end is collide with D's beginning, and like this it is happening over here. So now here what, whenever the collision is occurring, you need to find the vulnerable time. Okay, based upon that you need to calculate the back of time, how much time you need to wait. Now here if you are going to look at that, let the frame time denotes the amount of time need to transmit the standard fixed length frame. Okay, that is what exactly you are going to take a frame time. Now at this point, now here you are going to assume that we are going to use a Poisson distribution with a mean of n frames. When you are using a Poisson distribution with that, now here if you are going to look at that, this is the formula. See, the probability that k frames are generated during the given frame time in which g frames are expected. Okay, then based on your Poisson distribution, we are going to calculate like this. But when it will comes to the probability of 0 frames, here probability of g frames we are going to take. But if we are going to take a 0 frames is just e to the power of g. Now, so, but when you are going to talk about an interval, here we are going to have 2 parts. Okay, that is the 2t. Okay, so now here if you are going to look at that, in an interval 2 frames time long, the mean number of frames generated is 2g. So ultimately entire vulnerable period is p0 is equal to e to the power of minus 2g. Now when you are using the s is equal to g p0. Now that was the reason. Now here when you are talking about g is a 0.5, you are going to get 0.184. Now even if you want more, you can read this particular paragraph again. Okay, see, this is a paragraph you need to read so that you can understand what exactly the vulnerable time and all, so which we are going to calculate. But when it will comes to slotted aloha, in the slotted aloha, what I said, see, pure aloha was suggested by Abraham, and slotted aloha in the 1972, Robert has published. Okay, so against to that particular thing, Abraham's thing, where what he is doing, that he is dividing the time into discrete intervals. Yesterday I have shown that. Okay, so always the frame transmission is going to start at the starting of the time and it is going to end with the end of the slot. So now this approach requires the users to agree on the slot boundaries. That is what exactly I said, start and end slot. Okay, so now the point is what is going to be happen over here. So one way to achieve synchronization would be to have one special station emit a pip at the start of each interval like a clock. Whenever you need to indicate where it is starting and then where it is ending that. So some signal, pip signal we can keep it. Now when we are going to look at that, so in this Robert method, what is happening? Slotted, we are creating the slots comparative to your Abraham's pure aloha. Okay, so now in the Abraham's pure aloha, what happened? A station or a computer is not permitted to send whenever a carriage return is typed. Okay, but here what we are going to do instead, it is required to wait for a beginning of the next slot. Means I have divided in the slot. Once in that particular slot, if one is sending it, no other can send it. That is what yesterday I have shown to you people, that in the slotted aloha you can have a look at now. Imagine everyone can send. See, in the pure aloha what happened? The beginning of the ending of the frame is collide with the beginning of the other frame, isn't it? But in the slotted aloha, whether you are going to have like that, no. Whether you are going to have such a problem, no, because the frames are going to be sent at the starting only slot. Now if someone is having the data to send at this slot, okay, this point of time, no, they cannot. They need to wait up to this particular slot to starting. Okay, So that is what exactly the intention of this particular slotted aloha. Now, so instead, it is required to wait for the beginning of the next slot. Now, thus the continuous pure aloha is turned into discrete one. Now we are divided it into discrete. So when we are dividing that into slots, the best we can hope for using slotted aloha is doubling. That is 37% of the slots empty, 37% of success, and 26% of collisions. So dear friends, here if you are going to look at that, comparing to the pure aloha, compared to the pure aloha, in the pure aloha, the success rate is 18% only. Okay. But when we are going to talk about the slotted aloha, okay, when we are going to talk about a slotted aloha, now here approximately the 37% is a success and 26% is a collision. Now it is indicating that I am not able to overcome the complete collisions. Still, the collisions are there, but over this particular method, slotted aloha is going to give a better performance. But still, only I am going to achieve 37% only. This I may not be interested. So I want more success rate. So that was the reason we are going to the next method, next protocol called carrier sense multiple access protocol. This we are going to call as CSMA. CSMA. Everyone, please remember, this is going to be known as CSMA protocol. CSMA, Carrier Sense Multiple Access Protocol. CSMA, Carrier Sense Multiple Access. In the carrier sense, what we are going to do now? In the slotted aloha, what we said, we have divided it into the slot, and anybody is having a data to send, only they can send at the starting of the slot only. Okay. How to identify the starting of the slot? It is going to give a peep symbol or like that. And in the pure aloha, what happened? No one is going to wait for no one, and no restrictions or anything. Whenever anybody is having a data, they can send it. But with that, what is happening? Almost 99% of A's frame as reaching, about to reach, and that 1% what happened, it is collide with the B's frame. Now what happened? Both are supposed to be discarded, both are supposed to be retransmitted. Now that was the problem. In the slotted aloha, what we have done, we have divided it into the slots. But even in that, what happened, only the 37% only we are going to achieve the success rate, only the 37%. Okay. So when we are going to talk about the 37%, okay. So now here my intention over here is, see, with the slotted aloha, the best channel utilization that can be achieved is 1 by E. But if I want to increase it, I can have another method, carrier sense. How I am going to use this carrier sense? Now here, if you look at that, protocols in which station listens for a carrier. Okay, that is nothing but, carrier is nothing but what? A transmission medium. Now, if you are sensing the channel is busy, don't transmit. If you are sensing the channel is not busy, then you transmit it. Now that is what we are going to tell you in the sense, station listens the carrier and acts accordingly are called carrier sense protocol. In the carrier sense protocol, in the carrier sense multiple access protocol, without listening to the channel, you cannot take the decision. First, you need to listen the channel, and if the channel is ideal, then you can send it. If the channel is busy, you can wait. Now here, if you are going to look at, okay. So now when you are going to look at the CSMA, carrier sense multiple access, okay. Now this carrier sense multiple access, can reduce the possibility of collisions. See, our main intention is what? Whenever I am going to send it, I best utilize the medium and where I should not get any collision. Now, see, always the point is, if I don't want to get the collision, now what I should do? I need to do some mechanism. Now, that particular mechanism, what we are going to say, okay, here. The probability of collision still exists because of propagation delay. Anyone have understood this particular thing? Dear friends, I am asking you. I am asking you only. You have understood this particular statement, or shall I explain? I am asking you only. Everybody was there or not? Paridhi?
Yes, sir.
Yeah, I'm asking why no one is responding. I'm asking that our main intention in the CSMA to reduce the possibility of collision.
Yes, sir.
Now, in contrast, here the statement you see, the possibility of collision still exists because of propagation delay.
Yes, sir. Understood. There is still one condition due to which collision can occur.
What is that condition?
Sir, propagation delay.
What is the meaning of that?
Sir,
That is what I am asking, that whether have you understood or shall I explain? Shall I explain?
yes, sir. I mean, one more time, sir.
Now, here you can have a look at. Here, if suppose A is transmitting it, okay? See, there is A, B, C, and D, okay? Now, imagine when you are going to talk about, this is a timeline, okay? Now, here, B starts at time T1, C starts at time T2, okay? Now, when B was started at time T1, whether C is going to sense the channel ideal or busy? Paridhi?
Yes, sir.
I've asked the question to you. B is starting at the time T1. C
Yes, sir.
starts at time T2. Here we have indicated. Now, when B was started at time T1, and when
Yes,
C
sir.
is starting at time T2, now when C is sensing the channel, it is going to sense the channel as busy or ideal.
Sir, if BA started before, so busy, sir.
Never. That is what you have to understand, the propagation delay. See, B was started, but the point is this particular thing, it is reaching to the C at this time. Now, where at T2 time, already it is sensing the channel as ideal because of this
Yes,
propagation delay. Now you have understood.
Okay, sir.
Now the point is, see, B was transmitted over here, but it need to
Yes, sir.
transfer to this. So where once if it is crossing to the C, then only C is going to sense the channel as busy.
Okay, sir. Understood, sir.
Yes. Based upon this particular thing, see here you can look at that. When a station sends a frame, it still takes time for the first bit to reach every station. If A is sending a T, the first bit to reach to B, it takes some T plus X time.
Yes, sir.
That we are going to talk about the propagation delay. Due to that, what is going to be happen? And for every station to sense it, okay, a station may sense the medium and find it ideal. So only because the first bit sent by another station has not yet been received. This is what we are going to talk about, the propagation delay. Due to that propagation delay, there may be a chance of collision. Now you understood?
Yes, sir.
So now, based upon that, what we are going to do in the sense, now here if you are going to look at, see, this is what exactly is going to be happen. You see, when A is sending over here, so now B is sensing over here, C is sensing over here, D is sensing over here. So now what is your vulnerable time is equal to propagation time. Okay. See, I am not allowing the Manoj Reddy because he is not having the hall ticket number. But please inform them again. So now this is the frame propagation.
Okay,
Now this propagation delay, which we are going to talk about. So now you can understand that the see, when A is sending immediately, B, C, D is not able to sense the channel as busy. So during this particular time, see here the ash is shaded this whatever that it is there. Okay. So during this particular period, your B, C, D is also sensing the channel as ideal. Okay. Until this particular period, and what is happening, if it is sending any frame, there may be a chance of collision. So to overcome that, we are going to propose some methods. Those methods called persistent methods. What we are going to say? Persistent method. So what should a station do if the channel is busy? Okay. So what should a station do if the channel is ideal? Now these are the questions how we are going to ask, how we are going to solve that. So how many methods we are going to have? 3 methods have been devised. What are those 3 methods? One persistent, non-persistent, and P-persistent. Note down. One persistent, non-persistent, and P-persistent. Now, what is one persistent? In the one persistent, what I am going to do is, I am having some data to send, but what I need to do, I need to sense the channel. Now I am sensing the channel. Now channel is busy. When channel is busy, what I need to do? Continuously I am sensing the channel till it become ideal. Until the channel is ideal, it need to continuously sense. Now what is happening? So in the one persistent, I am keeping that node under wait. Continuously it should sense. Okay. But the problem, what is going to be happen with this? Wastage of time. It does not know when it is going to be ideal. So now here, if we are going to look at, see, persistent and non-persistent CSMAs. See, the first carrier sense protocol that we will study is one persistent. In the one persistent, what we are going to do, when a station has data to send, it first listens to the channel to see if anyone else is using. Okay. Then what it is going to do, if the channel is busy, the station waits until it becomes ideal. Then when the station detects the ideal channel, it transmits the frame. So but the question, what is going to be happen, imagine here when I am talking about continuously sensing, continuously only you are sensing? No, I am also sensing. If two nodes are sensing the channel continuously, and all of a sudden two has sensed it ideal, two are transmitting, then there may be a chance of collision. There may be a chance of collision. Then when collision occurs, what the station has to do? Waits for a random amount of time and starts over again and starts over again. So this is how exactly it is going to be happen in the one persistent. But continuously you must be there. So if suppose something you are going to have a work, okay, why I need to continuously sense, okay. So in that particular situation, we will go to the another method called non-persistent. What is a non-persistent? You come whenever you have a data to send, you come and sense it. If you are sensing the channel is busy, then wait for some random amount of time, come back and sense it again. So now you see, I am not going to say continuously sense. Okay. Then now after again, if you are sensing the busy, then again you wait for a random amount of time. But here, if you are going to look at the random amount of time of this period, and this period is more. Now that is what I told to you, that binary exponential back off, binary exponential back off algorithm you have to use, and based upon that your wait time should increase every time. Okay, now suppose here also if you are sensing the busy, then you need to wait and still more than this particular wait time, more than this particular wait time, and then again you need to come and sense. Okay, so this is what exactly is going to be happen non-persistent. See, in the non-persistent, what is going to be happen? A second carrier sense protocol is a non-persistent CSMA. In this protocol, before sending, a station sends the channel like the same, and if no one else is sending, the station begin doing itself. There is no problem. But if the channel is already in use, it waits random period of time and then repeats the algorithm. Consequently, now this algorithm leads to better channel utilization but longer delays than one persistent CSMA. One persistent CSMA, but better channel utilization. Now, my question is, now see, ultimately the important aspect over here is, so non-persistence is okay, but the point is you may question, okay, sir, continuously if I am sensing and now here I am waiting it. Now this particular wait time, somebody is coming and sensing it, and here the channel is become ideal. Now you see, your wait time is up to this, but here the channel is become ideal. Then how I should do that? Now again, I'm sensing it as a wait, and again. So someone is coming over here and sensing the channel and it is ideal, they are using it. Then, so that is the reason I'm going to say that longer delays but better channel utilization. Longer delays are there. Okay. Now, to overcome that, what we are doing in the sense, the third method. What is the third method? P persistent. What is the third method? P persistent. Now the P persistent is nothing but we are combining the one persistence and non-persistent, and we are calling it as a P persistent. Okay. Now here in this one, what we are going to do, initially continuously it is sensing for some time, and after that it is converting it into non-persistent. Okay. So this is what exactly is going to be happen. Now here, if you are going to look at the diagram, okay. So in the one persistent, what you are going to do, you are going to sense the channel continuously. If the busy, again sense it, and if it is ideal, transmit it. So in the non-persistent, if the channel is busy, wait randomly and come again sense, and if it is ideal, you do it. Otherwise busy, wait for randomly and again do it. But when it will comes to this P persistent, now in the P persistent, first what you are going to do, so continuously you are going to sense the channel. Okay. So now if, see, still if you are not going to do that, okay, so what you can do, so now here you are going to do that probability outcome. Okay, based upon that particular thing, so you are going to say wait a slot, and then you again come back over here, use the backup process through the collision occur. So now whenever it is happening like this, so you can continuously sense it and you can transmit it based upon that. So this is what exactly we are going to talk about. Non-persistent. So everybody have understood the CSMA? CSMA, see, carrier sends multiple access protocols. Under that, so persistent and non-persistent CSMA according to your Forougham and according to your Tenenbaum. Okay. Then the next one is CSMA with collision detection. Okay. This we are going to call it as CSMA by CD. CSMA by CD. Carrier sends multiple access by collision detection, or CSMA with collision detection. Now, when we are going to look at the CSMA with collision detection, so we are going to have another two random access protocol, CSMA by CA, CSMA by CD. Okay. Now, when we are going to look at the CSMA with collision detection, okay, so now here if you are going to look at that, if two stations sense the channel to be ideal and being transmitting simultaneously, then they will both detect the collision almost immediately. Now here, in that situation, whenever you are detecting the collision, rather than finish the transmitting their frames, okay, which are irretrievably garbled anyway, means once if the things were happened and immediately if the collision was occurred immediately, what you do in the sense, you please stop it, okay, instead of transmitting the garbled frames. So they should abruptly stop transmitting as soon as collision is detected. So now what is the meaning of that? In the sense, I want to improve the performance of the network, okay, or medium. So now you imagine the medium has been censored by the two stations and two stations were sent it, and immediately the moment if both are collide, immediately every station can identify or can sense that there was some collision. Now, when there is a collision, why we need to wait and why we need to allow other traffic into that? So now in that particular situation, what we are going to do in the sense, quickly terminating damaged frames saves time and bandwidth. This is a very important, okay, this is a very important point in aspect of that. So now this protocol is known as CSMA by CD, and this protocol we are going to use in the traditional LANs and MANs. Okay, so very importantly, okay, so very importantly, this point is valid for very valid for us, and this CSMA by CD throughout this particular subject which we are going to talk about. Okay, now so okay. So now when we are going to talk about this first bit, the moment if suppose it is identifying here, okay, the collision occurred, then now here it is taking a lot of time. See why I need to transfer it. See, it is going to take T1, it is sending T4, it is going to identify A's collision detection and abortion. And here C's collision detection and abortion. Now the point is the time we are wasting it over here. Instead of that, what we are going to do in the sense, the moment if suppose you are going to, okay, in this immediately you need to detect and you need to abort. Okay, so now here if you are going to look at that, here if the collision is occurred and immediately A detects the collision and aborts, and here C detects and aborts. Okay, so now this is what exactly is going to be happen. So now, so here, so how it is going to work? Sir, CSMA by CD is containing the CSMA carrier sends multiple access. Yes, absolutely, dear friends. So CSMA is nothing but immediately the three methods should come into your mind. One persistent, P persistent, non-persistent and P persistent. Now, in the CSMA by CD, again the same thing which we are going to use K, and this is the TP to transmit the propagation time, average time which we need to do. Based upon that, we need to calculate the backup time, wait time when collision is there. Now, so how it is going to start? How your CSMA by CD is going to work? So initially a station has a frame to send. Whenever a station has a frame to send, assign the K as 0, and apply one of the persistent methods because it is a CSMA by CD, because it is a CSMA only. Okay, so CSMA, either you can use one persistent, non-persistent, P persistent, any one of that. Now, so whenever it is eligible for transmission, whatever the method you are using, whenever it is identifying the channel is ideal, then the transmission is done. Okay, now if the transmission is done or collision detected, now what you are going to do? See, imagine if suppose transmission is done, then transmit and receive. Okay, but if suppose collision is detected is yes, what you are going to do? You are going to come over here, collision detected. When collision is detected, then if collision is not detected, it is success. If collision is detected, what you do? What you have to do? You need to send a jamming signal. Dear friends, please, this is you need to notify. Jamming signal you need to send it, and due to this jamming signal, what you are going to do immediately? You are going to abrupt the transmission and you are going to increase the K, and this is going to be continued for 15 times. Okay, so if you are going to do that, after that you have to stop it and again you need to come back, and this is the same thing what we have discussed in the yesterday aloha. Okay, so now again you will come and you will do the same thing. Okay, if collision is not there, okay, you are going to transmit, and so if successful transmission, so no collision is detected. See, because why we are talking about over here, transmit and receive. Now here the things are coming over here. Okay, so now here if the collisions are not detected, it is success. Okay, so every time after sending it, it is going to listen to that, and if it is receiving that, okay, any signal, okay, if positive acknowledgement, okay, if collision is detected, then you need to do this particular. Okay, so this is what we are going to talk about, the CSMA by CD. CSMA by CD. Okay, so now this is how it is going to be happen. But the point is, so now here if you are going to look at the CSMA by CD, now here you can have a look at many other LAN protocols uses the conceptual model. Okay, what is the conceptual model? So at the point marked T0, a station has finished transmitting its frame, and any other station having a frame to send may now attempt to do so. If two or more stations decide to transmit simultaneously, there will be a collision. If a station detects a collision, it aborts its transmission, waits a random time. See, in your Tenenbaum, they are explained theoretically. In your Forojan, if you are going to look at that, they have explained it as diagrammatically. So ultimately the CSMA by CD intention is it should use the CSMA technique to allow the things. That is what you are going to look at that. You see frame transmission period. This is a contention period. In the contention period, no one should transmit it. Okay, and then again you are going to transmit. These are the contention slots. If anybody is there, they can compete for this, and like this it is going to be happen. So these contention slots are waiting time. Okay, so now here when you are going to look at that see, wait for a random amount of period and then tries again. See, assuming that no other station has started transmitting in the meantime. Okay, so now what we are doing in our model for CSMA by CD will consist of alternating contention and transmission periods, with ideal periods occurring when all stations are quit. Okay, so here we are using the contention. Now here that is what you can have a look at over here. Frame transmission, and here what we are doing, anytime if suppose you are having a collision, so this is a contention time. See here you can have a look at, here you can have a look at, here you can have a look at. No one is going to do that. No one is going to transmit it. So this, and then we are going to allow the frame transmission, so that which is going to use a better channel utilization. So now ultimately, but here when it is, see, after transmitting a frame, if I'm not going to wait, and if immediately if I'm going to send it, and if the two channels are sensing the channel as ideal, and if two are sending it, we are going to get a collision. But to overcome that, what we need is, we need to modify it to that collision free protocol. Under this collision free protocols, we are going to use the bitmap protocol. Okay, and we are going to use the bitmap protocol. Please, you can note down, this is a very important question. Collision free protocols, you can type collision free protocols, you will get some of the material weeks for weeks around that. The methods you can please note down. Now here you can have a look at that. See, almost collisions can be avoided in CSMA by CD, but they can still occur during the contention period. During the contention period, if two channels are two stations are sensing it as ideal. So to overcome that, what we are going to do, discuss some protocols, resolve the collision during the contention period. What are those four? Note down: bitmap protocol, binary countdown, limited contention protocol, and the adaptive tree walk protocol. Everyone have noted down? Collision free protocol. Collision free protocols in your exam, when they are going to ask you, you need to explain this particular thing. Collision free protocols in computer network, you need to explain about bitmap protocol,
Okay, sir.
binary countdown, limited contention, and the adaptive tree walk. Okay. Now, if we are if we are going to look at any doubt?
No, sir, you can continue.
Yeah. So when we are going to look at the collision free protocols, in the collision free protocols, when we are going to talk about a bitmap protocol, if we are going to talk about a bitmap protocol, okay. Now what is going to be happen, you can see. Now, if you are going to look at, this is a very important aspect. In our first collision free protocol, the basic bitmap method, okay, each contention period consists of exactly n slots. How many slots over here? How many slots over here? How many slots are there?
So 8.
Now that is nothing but, n slots is nothing but, in your network, how many users are there? 8. Now for 8, it is creating the 8 slots, and I am circulating it. And I am telling you content for your channel. If you want to send a data, mark in your node 1. Now after I am sending, now you see, if station 0 has a frame to send, it transmits a 1 bit during the slot 0. No other station is allowed to transmit during this slot. So regarding, so what station 0 does, station 1 gets, okay, if what station 0 does, the same way station 1 gets the opportunity to transmit 1 bit during slot 1. Now like that, when I have sent this contention slot, who have competed? Station 1, station 3, station 7. These are the 3 stations wants to send the frame. Now what happened? Now, now here if you are going to look at that, station J may announce that it has a frame to send by inserting a 1 bit into slot J. After all n slots have passed by, each station has complete knowledge of the which station wish to transmit. Now you see, once if this contention slot is completed, now you tell me who wants to transmit it? Station 1, 3, 7. So No other should transmit. No other should transmit in this particular period. So first we are going to allow the station 1 to send, station 3 to send, station 7 to send. Now whether you are going to get any collision over here? No. Then what we are going to do? Again we are going to send the contention slot. Now this time station 1 and station 5 wants to send. So we are allowing the station 1 and 5. Now the next time only station 2 wants to send, I am allowing the station 2. Now this is a bit which I am mapping it, and so that everyone agrees on who goes next. So there will never be any collision. Dear friends, everybody have understood what is a bitmap protocol? What is a bitmap protocol? Everybody have understood? Here, how many number of users are there? That many slots contention window, I am going to send it. And the contention window is going to be sent to every station. And if that station is having any data to send, it is going to mark 1 against to its column. And once if it is completing the content, the end users, end stations, and everyone knows that who else are going to send. Okay, so based upon that we are going to allow, and this is what we are going to call, it is a bitmap protocol. Okay, so this is how it is going to be happen. If 2 is there, only 2. If 1 4 6 7 is there, so 1 4 6 7 I am going to allow that. Okay, so this is what exactly is going to be happen. Then the next method is the binary countdown method. What is the next method? Binary countdown. Okay, so now when you are going to look at the binary countdown, okay, now we will have a look at the binary countdown. So in the binary countdown, what we are going to do over here? Now here, very interestingly, now here you can look at a station wanting to use the channel, now broadcast its address as a binary bit string, starting with the higher order bit. All addresses are assumed to be the same length, and the bits in each address position from different stations are Boolean ORed together by the channel, and when they are sent at the same time, and we will call this protocol as binary countdown. Now you tell me whether everybody have understood it or not. So that I will explain. Be fast. Have you understood? See, any station wants to use the channel, it is going to send its address with a higher order bits. And what channel is going to do? All addresses are assumed to be the same length, and the bits in each address position from different stations are Boolean ORed. Now you can have a look at over here example. Okay, you can have a example. See, when you are going to take the 0 bit 0011 0011, what you are going to get? 1. Okay. Now, when you are going to get 1, only these two stations are supposed to be given preference, because these two are having the first bit 1. Now, it is coming to the next bit 0. So, next two bits are 0. So, now this is again both are equal. So, I will go to the third bit. Now, in the third bit, what happened? 0 1. Now, when 0 1 is Boolean Z, so I am going to get 1. Now, who is having 1 position? Now, this. So now 1010 is going to give that. Okay. So now here, if you are going to look at that, see, the winner is station 1010 because it has the highest address. Okay. Now like that, it is going to be allowing the stations, which station should go first and which station should go next. And this is what we are going to talk about, is a binary countdown method. Fatafat, everybody have understood? Post in the chat. Everyone have understood? Fine. Okay. So like that, we are going to do the binary countdown. And then we are going to have, according to your textbook, we are going to have another one also. Another one is what? Token passing. What is another one? Token passing. So in the token passing, what we are going to do is, like in the bank, we are going to give a token. Okay. So a small message called token. Now, whoever is having the token, they need to send the frame. Okay. See, the token represents the permission to send. And if a station has a frame queued for transmission when it receives the token, and it can send that frame before it passes the token to the next station. So you obtain the token, you transmit it, and then you give the token to the next station. So, but here you may have a question, sir. If someone is getting a token and if he is not releasing the token, no, there will be a specific time period, and after the time period, automatically your token is going to be passed to the next station. Okay, according to the your token ring protocol or like that. Okay, in that one we are going to use a token passing mechanism. Okay, so this is how it is going to be happen, and which we are going to use in your FDDI, fiber distributed data transfer, where we are going to use this kind of token pass. Okay, token passing mechanism. Then token passing is one. Binary bitmap is down. Bitmap protocol is one. Binary countdown is one. Okay. Then another one is the limited contention protocol. This we will discuss in the next class. So the moment if the limited contention protocol and channelization is going to be completed, so your second unit is almost completed. Okay, because these are the collision free protocols. So just a minute, just I am opening. Okay. So now here, if you are going to look at carrier sense multiple access protocol, then collision free protocols. Okay, and here the wireless LANs and data link layer switching we will discuss in the next class. Okay, so this collision free protocols we are yet to discuss the limited contention protocol. Okay, see, limited contention protocol and adaptive tree walk protocol, that we will discuss in the next class. Okay, see, adaptive tree protocol is nothing but quite simple. You can check this one, Geeks for Geeks, and it is quite simply, you can it was explained how it is going to be done. It is something like a tree. Okay, this we will discuss in next class. Limited contention and that. Any doubts? Any doubts?